Hello guys, so welcome back to another session of Learning Unity with me. Where we last left off, I think we were learning coroutines, and um, we were able to now hold down the space button and continuously fire, and then when we let go of one of the fire buttons, that's when the fire stops. So I'm gonna demonstrate it like that. Wait, what the heck? that's that's funky. Alright, maybe maybe I was right about the gap. I guess it didn't show. Because I remember mentioning yesterday about like the gap, like that's why we needed to yield or wait, or that's why we needed to wait for a certain amount of seconds. In this case, 0 would reduce the gap. I don't know why it didn't show that yesterday. So now if we did the 0.1 f, it should show a decent gap in between the bullets, which makes it better, I guess. It looks better. So this probably is just design, just for the design portion. Or not. What is happening? Why does it look like this? I don't think it's supposed to look like this. Let me see how his looks. My god. Well, actually, yeah, let me just... Yeah, see, like there's a gap in between here. Why is that? Why does it load like that? Did it even compile? I think it did. Let's make it more obvious. Wait, what am I doing? We have the inspector right here. We can always just change it. That's what the whole point of it. So yeah, the projectile fire speed is 0. Huh. Oh right, so you can't really click on the mouse button. You can only do it through the space bar. So now it does it. But then when we go back to 0, so that's why. All right, that makes sense. I guess it wasn't properly updating in the actual like inspector, so that's why we didn't see results yesterday when we were changing the fire rate. I guess that makes sense now. Cool. So if I waited for 1 second, that's really slow. 1 bullet per second. How about 5 bullets per second? 1, 2, or actually it's not per second. I think this might be the rate I would go for, because you know he can't be shooting. For a human, he can't really shoot this fast. I mean, I guess he can, but with a pistol, that seems unlikely. So maybe you can make it 3. Yeah, I think that looks better. Actually, let's try 2. Nah, I think 3 is better. It makes it a little bit more challenging. You can't just keep spamming it. You have to like... Alright, let's continue. So that's his solution to um, prevent, because yeah, I did experience that just a moment ago. Um, so I guess for now that would be the correct solution. But I figured that I guess maybe how I see it is that like if we do want to alter the controls, um, we would probably put it in the settings or feature, right, where we would just switch the layout based on the user's preference. So technically we'd only have one positive button, but it can be switched out depending on the user's settings. I don't know how to do that, but because it'd be pretty cool to be able to switch it like from space to mouse, because let's say if I wanted to control the player with WASD and then shoot with the mouse button, or if I just want to play it with an arrow keys and then shoot with a space button, I think that'd be pretty cool too. So I guess maybe in the future we'll learn it, or maybe I could do it like outside of this outside of the course material. Alright, before I move on, I kind of want to review it because we are going kind of fast. So we just started coroutines, in which the method needs to return an I enumerator, and an I enumerator is essentially returns I guess an iterable. It's kind of hard to explain, but I know it's how I see it. It returns some kind of list, but it's not really a list that you can iterate through as it's returning new values. So basically, when we call this function here, it's returning something in loops, right? So basically, imagine this loop. So it's always gonna return for every loop, and that's gonna be a lot. But since it's an I enumerator, we're able to iterate through each of the object that was returned, right? So that's basically what it is. And I guess as a reminder, like it's not return like. So this is kind of similar to generators, I guess, where it doesn't store the memory at all. Like if we were going to return a list, we'd have to, store that somewhere and then return it to whoever's calling the function. And here we use yield return to return a single item, but a single item but multiple single items consecutively. It's kind of strange for me to explain it like that, but yeah, kind of like that. So because like we're looping, right? So we're gonna call this yield return you're gonna return a value for each loop, and that's gonna be a lot, especially since we know like the computer processes things very quickly, and so basically it's returning that many wait for seconds, right? And so basically we're waiting for that many seconds as the while loop is going forward. And I guess in a way those individual items are actually placed like within the container, I guess. And then but the thing is we're returning an I enumerator for each of them, so we can iterate through all of them. Yeah, sorry if that sounded confusing. I'm still trying to get it. I don't know if that's the right way of saying it. If that isn't, then please correct me, because yeah. Alright, so we know that this will always be generating a laser, and we'll only generate a new laser after a certain amount of time, which in our case would be 0.3. So it would wait for 0.3 before it would generate another laser. And we started that coroutine in our fire method, which gets called in the update. So it's like, since if we're holding down the space button, which is one of the positive buttons, or the positive button that activates the fire 1 action, it's going to get red from the update, and then it's going to see that we're still holding down the spacebar, and then it'll start the coroutine. I wonder though, like, because it seems like we're always going to be starting a new coroutine like while we're holding down the button. unless what I'm thinking. Oh, no, 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 no. My bad. I'm sorry. So actually, I guess there's a difference between holding the button down and then pressing the button down, because it only happens once. So if we're holding it and it gets called, nothing really happens in the second iteration when the update gets called again while we're pressing the spacebar, because this only reads if the button gets pressed down, and we're holding it down currently, and that's entirely different. So it's seeing it as nothing, like it's just not seeing it as nothing, but like it doesn't execute anything. So that other start coroutine, the beginning one that we press once we press the fire button, is still running, right? And that's the only one that is currently happening. And only when we release the spacebar is when the other if statement, this one, becomes true. Therefore, it stops the coroutine that we've initially made when we first pressed down the space button. Again, I don't know if that made sense, but I did my best for that. So that's how it basically worked, and we used coroutine here just so that we can continuously fire the lasers instead of tapping them individually. I don't see that as really an issue in the beginning, but I guess it's good to know. Like, oh, this is how you do it. I feel like it's kind of a little convoluted a little bit, because I wonder if there's like a way to see if the button's being held down, because I don't know, I guess from my experience, beginner experience with because I remember trying to mess around with input with a Java project, and yeah, we were able to read or listen to whenever a key was pressed, released, or when it's being held down. And I'm wondering if maybe there's something like that in C#, in which would make all of this kind of complicated, since if there's a way to just read if it's being held down, then we could just keep firing, then we let go, then it would just stop. Maybe there is, I don't know. I'll quickly check, and then if we can't find it, then I guess not. Unity on key hold or something like that. I don't know what it's called. I've seen some questions on the forum, but none of the solutions are working for. Basically, I'm trying to do this while the fire one key is pressed and held. I want to increase the value of test number by 1 continuously. Currently, when I run the script, I press the fire one button, held it down, but the value doesn't continuously keep increasing. It will only increase again if I let go or repress the button. Use that instead of get button down only returns true for the frame in which the button is pressed. So it seems like there is a way. Get button. So I guess there is a way. I guess he just wanted to show us this way. I don't know if this is more efficient, or maybe just the way it's handled is more efficient. But I guess we could have done it this way as well. I don't know if I want to try it because I kind of want to finish this lecture. Let's see. It says get button, so we're getting the fire one buttons. We're reading it, listening to it, and let me see. Share whether this is what Oh yeah, I can definitely see it's a little bit more complicated. Never mind. We're actually dealing with the time hold instead of. Then never mind. This actually makes much more sense. Like the coroutine part makes much more sense than actually dealing with the time. Yeah, this looks way more complicated. Never mind. Coroutines all the way. Well, for now, anyways. Alright, let's continue. Coroutines all the way. Sorry, it's kind of loud. Wait, actually, did I cover everything that I wanted? So yeah, that's basically coroutine, and we use coroutine to basically allow us to continuously fire a laser. Oh yeah, he's gonna mention it. He's gonna mention it. Yes, yes. This is one of the issues that I felt uncomfortable with because I didn't like how much all of that was still in memory. Because I imagine, like, let's say if we're playing a level, you're gonna be shooting a lot, and then having all of those in memory doesn't seem that efficient. So a good thing he mentioned it. Oh, maybe what I'm thinking, because he just mentioned there's a shredder. Like maybe if it reaches a certain point, we can delete the game object. Huh. All right, we can try. We can try. We don't need hints. We got this. All right. So we need to check if the laser is. How do we keep count of each laser? We do have it here. Alright, let's think about it a little bit. Let's see here. So we want the laser to delete. I forgot how to delete a game object. But we want to delete a game object once it reaches the position of the camera. But the only way to kind of reference the laser is in the I enumerator fire continuously. We can have an array that would be, you know, I feel like that'd take a lot of memory. Alright, let's see. Okay, I might be stuck here. Never mind, I do need the hint. What is the hint? Creating the game object called Shredder that has a trigger box collider on it. Right, that makes perfect. Then we just need to do the on collision detection, right? And if they collide with this object, then we delete it. Pretty smart. That's actually pretty smart. Whoa. That's alright. So we're gonna go here. I guess in our not canvas. My bad. We're gonna create an empty. We're gonna call this the shredder, and then we're gonna create a box collider. Oops. Not this one. We need box collider 2D, which is right here, and then we're gonna move it towards here, which is in the camera. We're gonna make it kind of intercept just to make sure that there's no gaps that I can go through. So we're gonna wait, what? Oh, right. So we click on this, and then we extend it all the way to the side. And then do we want to make it is trigger or collider? I think is trigger would be a better one, because they can still pass through, but then by the time it passes through, it can get deleted. Because if we made it non-collision, we can definitely see it disappear. We can still we could still see it like disappear in front of us, because you know it can't even pass this. So we'll see the laser here, and then just disappears. As opposed, if we kept it as trigger, it'll still go through, but by the time it goes through it, it gets deleted. I don't know if that made any sense, but we're gonna go this way. Oh yeah, we gotta. Well, we don't need to reset the transform since we already placed it here. But yeah, so now we have the loose collider or shredder. Let's see. So now we gotta figure out how to detect when a laser. Wait, the laser does. Oh, we also need to add a collider here as well. So let's go create a box collider for lasers. I can't really see that. Let's just go here for the time being. Let's go player laser. I think that's good enough. So actually, let's just delete that. So, alright, I think that's good enough. Yeah, so it's gonna match the overall thing. Yeah, that's good enough. So how do we detect that then? Probably have to make a script. Right, I think that's what we gotta do. We gotta make a shredder script. So we're gonna do shredder or script, create add. Oh wait, we gotta first go to our assets, move this to scripts, and then edit it. Just to stay organized. So once we have it here, we're gonna delete everything because we don't really care for it. And we're gonna do on trigger, enter 2D, collision 2D, other. I'm not sure if that's how it is, and just make this public, or I guess private. It's fine. Private on trigger, private void on trigger 2D. Let's go quickly just verify that. On trigger enter 2D, collider, not collision. Alright. Collider 2D. Where's it? Collider call, and then any game object that touches this will get deleted. But we gotta make sure that it's laser. if a player touches it, you know, it's game over. But luckily we have padding, right? So he can't even touch it. So that's good on us. Alright, so we gotta delete it. So I forgot how to delete. So delete game object in Unity. Destroy. Alright. Done. But if I remember correctly, and I just want to bring it up just so I can kind of connect things and make things a lot easier for me, or not easier, but like so I can get a better understanding of like everything revolving around Unity. So I remember destroy in the life cycle of like how Unity does it. It actually destroys the game object at the end of the life cycle. So let's look at Unity 2D life cycle. I don't know. I think there's a difference between the 2D life cycle and the 3D life cycle. Is there? I think there should be a difference, right? So yeah, on destroy happens at the end. So yeah, because I remember that because we had an issue with that in regards with the what was it? I think it was the game status from block breakers, and even though we wanted to delete it in the beginning, the first reference, like, it doesn't get destroyed until the end, so it was still referencing to the new game status. Because remember, we were using the singleton design pattern, so only one of that instance existed throughout the whole span of the project, and we deleted any new instances that was created if it was greater than one. And I'm bringing this up just as a reminder, like, alright, so this, if we're going to delete the laser, it happens at the end of the Unity lifecycle. You know, just in case if we're trying to do something else and then like something's not working, that might have something to do with the lifecycle. So let it compile. We have a shredder here, it has this thing, so let's go check see if it works. Alright, so we're gonna watch over here. What? It still passes through. What? Maybe I didn't do that right. On trigger, enter. Collider 2D. Destroy other. On trigger, enter 2D. Collider 2D. Call. I added the lasers, right, to the prefab. What I'm thinking, it's that it didn't get updated. Oh no, it should have. Never mind. But just to be safe, let's try that again. Maybe that was an issue. Nope. Alright, so wait, I thought I changed that. Wait, what? That's odd, I thought I saved that. So it does read it. Huh. Alright, then let's try the on collision enter. Or maybe we have to set it as, because it does happen in the end, so I'm thinking maybe we deactivate it first and then we destroy it. on collision, enter 2D, collision 2D. Wait, why did I get an error? Cannot convert collision 2D. Oh. How to wait. First of all, let's convert that to oh yeah, we could also do this. We can destroy it after 1 second. Get type. So we have to do get type. Bug log. How about say other thing? Oh yeah. This is the type. So other dot type. What is this anyways? What is actually? Oh, that's weird. Wait a minute. Yeah, it has a box collider. Wonder why they're not colliding. Probably forgetting something. They don't have colliders, what the heck? They say they do, but yeah, I don't see the collider. I'm stuck. But essentially, if I got to work, I guess this is what we would have done. We would have used a collision enter and then destroy it for any objects colliding with the shredder. That's what we would do. But I guess I'm getting stuck here somewhere, so I'm just gonna see what he does. Oh, it says trigger. So it is supposed to be trigger. So let's go ahead and delete this. Oh, you know what? No, I'm gonna continue. Like I feel like I'm almost there. I'm just missing something. Did it compile? Did it compile already? Yeah, it's not deleting, which is odd because it is printing it out. Can we set it to act like? Let's try changing it the active to false. Set active. Let's see if that works. Oh wait, what? Does not contain set active and no accessible session methods. So probably have to do. Wait a minute. I wonder if we have to do this. Oh my god. Wow. I mean, it makes sense. I mean, it wasn't really a game object, it was a collision 2D object. And so I need to get the actual game object. Because that's the thing we were trying to delete. Makes sense. Yep. Makes sense. Makes sense. Alright, so we got it. Nice. I think what gave me the idea was because I think the other line of code that I tried to do, I was gonna print out, or I was gonna dang, I forgot. What was I gonna do? Because, yeah, I remember, like, it doesn't have that method. Like, wait a minute. Oh yeah, game object has that. Like, oh, I see now. So we're supposed to actually get the game object of the other one. Hold on. Alright, well that's done. Sorry, my dog kept barking. So yeah, so this works now. So let's continue on with the rest of this. And good thing we found it. Alright, I gotta remember that. The game object property. Yeah. One more thing. One more thing needed for laser. Oh, it's the box collider. the box collider. Yeah, I forgot to do that. Oh, I guess that would have been better. But I guess the reason the way I the way I did it, it should be fine as well. Like it's really close, but it should be good. Oh dang, that actually does look better. I'm gonna actually change it because it just looks way better as that. So just gonna change the box slider. Oops. Going to remove this. Then we're gonna add a component. We're gonna make it a circuit. No, some. I forgot what it's called. Capsule collider. That's what it is. And then should be in the center. Yep, perfect. Right. We just test it out. Does that look kind of off? I think it's fine. I know you're not focused on it, so that should be fine. Wait, what the? That's pretty interesting. The way he reacted to it. All right, another quiz. All right, let's go. The most important thing to work on first for your game are what? The core features. Tuning and polish, I think, happen at the end. Core features, like, that's the thing you got to get focused on. The most fun features, I don't know what that actually means, because that could also be in the core feature or secondary. Secondary features are the things that we worry about less, so kind of like 1, 2, 3 type thing. Where in Unity can we change the button mapping for our game? Input manager. Which of the following blocks of code will allow us to print something cool to the console, wait for 5 seconds, then print something else cool to the console? So they all have IEnumerator, so which makes the function a coroutine. So we have debug. So we only they all have debug, so we can't focus on that. So the thing we should be focusing on is yield. So we have yield wait for wait for seconds, 5. No, we're missing the return. Wait for seconds. Wait, what? Which is incorrect? Aren't all of these the same? Yield, return, new, wait for seconds, 5. Oh, the semicolon. Wait, this doesn't even have semicolon. What? Get out of here. And this one doesn't have the function, so it's this one. I don't know if that was the right way to do, because that was kind of confusing since these three look the same. This was just missing the semicolons, and this was missing the function header, or the parentheses for the function. How would we start coroutine? Called I'm a coroutine. This way, start a coroutine, I'm a coroutine. Actually, not the function. Since I'm a coroutine, is still technically a function. We do have to call it like a function first. We can do it like this, but it's kind of overkill, so we're gonna go with this one. Look at the following image and then answer the question. Why are our lasers not being destroyed by our trigger volume? What? Why are our lasers not being destroyed by our trigger volume? Trigger volume. Yeah, I don't know. I think he's referring to the last part that he mentioned before he activated the is trigger feature on the Shredder's Box Collider 2D, and that's because it's not triggered. This one. Our Shredder transform has not been reset. Our Shredder, our laser has not been saved. It is saved, or I guess for my sense it is saved because it's automatically saved, but for, I guess in this version you have to manually apply it, so I guess that's a little different in that sense. Create list of waypoints. I wonder what that is. Oh, I think I know what he's gonna do. So basically, oops. Oh, that's not what I wanted either. So basically, I'm assume that since these are indexed as 0, 1, 2, 3, 4, 5, etc., we're just gonna make the enemy go to the position, to those position, and that would be called path 0, or technically the first path. And then I guess we'd be making different paths based on the enemy type. I never thought about it that way. I guess this is kind of like pseudo AI, kind of. Doesn't really, actually, no, never mind, it doesn't. Since, well, I mean, let me think about it. I'm gonna go with a little bit, just a little bit, like that. Or it's pseudo AI would be a better word. It looks like the enemy is thinking, but in reality, it's being controlled by the path that we set it to. So I guess the main use, or the reason why we're shifting, is this dynamically part. Because for an array, we would have a set size for the data structure, but if we're playing a game, if we're not entirely sure how much we're going to be storing, so by having a list, we don't need to worry about it because we can just keep adding to it without any restrictions, essentially. I think that's what he's trying to say. So this is the type of objects that the list will store. Collection size, fixed variable. Performance fast. List varies. So arrays are faster because each element is stored into memory. So when we're indexing the actual object in the array, right? It'd already be in computer, so it'd already be in the computer. So I mean, not computer. It'd be already be in the memory, so we can just easily, look for the address of which the object is located at, and we could just, pick it up. But for a list, it's entirely different. Instead, the first object is only stored in memory. And if in order to check the rest of the objects, you would need to iterate from the beginning object to the object you're interested in, and that takes a certain amount of time depending on how big the list is. I'm sorry if I'm just explaining things. That's because I just want to kind of review what I've learned, and it just helps me kind of connect things together, because this is actually pretty interesting. Even though I have already learned this, being able to see it implemented in another another curriculum or another something, even a hobby like this, is very interesting. How everything is connected, and that's very interesting to me, and it helps me review a little bit because I am forgetting these things. Alright, so we're given it this challenge. So first of all, let's create the path of for our enemy. So we're gonna call it similar to his path 0, and then we're gonna create a empty parent. Oh no, I bet. Create an empty. We're gonna call this waypoint 0. Then do 3. Yeah, how did he do this? We can just change that to 1 and then 2. So then we have the different waypoints. So we can actually put like a point here. So it's right here. Then we're gonna do the same for everything else. I wonder if we can make a prefab out of this waypoint, and then we can just make them all the same. And yeah, they're all reset, so I think it should be fine. So let's go to W. So we're gonna make the zombie kind of like zigzag, I guess, like go here, go here, and then go here. So that'd be our waypoint, and then we're gonna create a script for the zombie enemy. We're gonna create a C# script, and this is called enemy pathing. That's not what I wanted. Fortunately, let's try that again. Create C# script enemy pathing. I think that's what it's called, right? Enemy pathing. Oh wait, I just realized 1 hour. Yeah, I think I'm gonna end it here for now, and then we'll continue where we left off from here. And I'll probably try to review this because I do want to get this right, or at least get the gist of it before we continue. Alright, so I'm gonna end it here, and I'll see you guys tomorrow. Peace.